5.2. All right, so first off, we've talked about these before. What do we mean? What do we mean when we're talking about an identity? What is an identity? Something that's always true. So when we want to verify that something is an identity, we want to show that it's always true. When we're verifying identities, they're written as an equation. We don't know starting out that they are equal. We want to show that they are equal. So we can't work across the equal sign. So we can't work like we're solving an equation. So we're not working across the equal sign. We have to show that they're true. We don't know that they're true. We don't know that they're equal. So what we want to do is work one side only. So we want to, and usually we're going to pick the most complicated side because that gives us more stuff to work with. So we work one side only. The most complicated side, usually, because we have more to work with. I'm not going to say always. And there's some other tips that are written on that sheet that I gave you. As a last resort, you can convert everything to sines and cosines. So what I want to do is just go through some examples of verifying identities using things that we already know, following these guidelines to show some examples, talk about how we go about these things. It's important to remember one common mistake that people make is they want to work like we're solving an equation. So you can't add something to both sides. You can't divide both sides by something. You don't know that they're equal. You're trying to show that they're equal. All right, so let's look at some examples. All of our examples today are verified. So we want to verify sine squared x minus 1 over sine squared x equals minus cotangent squared x. So we want to show that we can turn one side of this equation into the other. So which side should we work? Work the left. So that's the most complicated side. Work the left side. So let's start out with what we know. Sine squared x minus 1. What is that? What is it? Okay, do we know an identity for that? No, but we do know that sine squared x plus cosine squared x equals 1. So sine squared x equals 1 minus cosine squared x. Let's take this and substitute it in here for sine squared x. So I have 1 minus cosine squared x minus 1 over sine squared x. And I have a 1 and minus 1, so that equals minus cosine squared x over sine squared x, which equals negative cotangent squared x. And we're set. We showed that we could turn this one side of the equation into the other side. This isn't the only way that's possible to do this one. Someone in the last class came up with a different way. I've done it a couple of different ways. So So often with these, there's several ways that you can go about it. This is just the one that popped into my head first, is substitute for sine squared x. Yes?
I'm confused with the sine squared x over the on the right side.
Here?
Yeah.
Well, the sine squared x is our denominator here.
Oh.
So we didn't do anything. We didn't do anything with that. We just left that as our denominator. So all we did was work with the numerator. So I substituted. Let me draw an arrow here. I put this in right there. So that's where that 1 minus cosine squared x is. So I didn't do anything at the bottom. Okay? Yes? Is the answer all the... Yes. Yeah, the answer is the work. The answer is that you show that you can turn this into that. So this, we already know where we're supposed to get. The problem with these is showing how you do it. Okay? I'm sorry?
So it's like a proof.
Like a proof, yes. We're proving that this equals this. Exactly. All right, good questions. Good questions. All right, let's look at another one. So I just want to do a bunch of different varieties so you see some different things. All right, 1 over secant x minus 1 minus 1 over secant x plus 1, and we want to show that that equals 2 cotangent squared x. All right, didn't we do one just like this just recent? Just like right over here? Before we wrote that one up? Didn't we do one like this? Where we're subtracting these two fractions? What did we do to subtract those fractions? Common denominator. So I'm going to multiply this by secant x plus 1 over secant x plus 1. And I'm going to multiply this by secant x minus 1 over secant x minus 1 for my common denominator. And then for my numerator, I have secant x minus this whole thing, secant x minus 1. And for my denominator, I have secant squared x minus 1. I have a secant x minus secant x and a minus minus 1. So I get 1 over secant squared x minus 1 is tangent squared x plus 1 equals secant squared x. So secant squared x minus 1 is tangent squared. Did I have, I forgot something here. This should be a secant x plus 1. So when I multiply this, I forgot to write my plus 1. So this should be a 1 minus negative 1, so I have a 2. And that's 2 cotangent squared x. So I show that I can get from this side to this side.
So wait, is it ever going to be like a way down?
It can happen. Usually the ones that I give you, you go through the steps to show that they are equal. It's kind of tough to when you get the ones where they actually aren't identities. So in general, I'm going to give you ones that they do work out, that you can get from one to the other.
Okay.
All right, questions on that one? All right, let's look at another one. Sometimes the ones that look intimidating are the easiest ones. So we want to verify this identity. So what could we do here? So which side do we want to work? Work the left, that's the most complicated side. So with the left, what would we do? We could multiply this out. We'd end up with a cotangent squared x times a sine squared x. So thinking ahead, that looks kind of like it could get messy. But let's look at this 1 plus cotangent squared. Don't we have an identity for that? Cosecant squared. So this is cosecant squared x. 1 minus sine squared. Cosine squared. Well, cosecant squared x is 1 over sine squared x times cosine squared x, and that equals cotangent squared x. So that one turned out to be pretty easy. We used our Pythagorean identities for each set of parentheses. We could get the same place if we multiplied this all out, but I think that would turn out to be a lot more work. All right, questions there? Okay, let's look at another one.
Wait, this is on the top of the tunnel, it's
Well, we knew that's where we wanted to get.
Right.
So we wanted to show that we could turn this into 2 cotangent squared x. Yeah, just showing the steps to get there. All right, let's look at another one. Still verifying. Secant x plus tangent x equals 1 over secant x minus tangent x. All right, so which side is more complicated here? The right? We want to work the right side with the fraction and the subtraction. So let's work the right side. Well, here we have a fraction, and we want what we're trying to get to is not a fraction. What was our technique? What was our trick for dealing with that? Multiply by the conjugate. So I'm going to multiply this by, and didn't we just do one similar to this on the board? Very similar. From last night's homework, we didn't know we were just simplifying. In my numerator, I have a secant x plus tangent x. That's what we're trying to get to. What do we hope that the denominator comes out to? 1. We hope it comes out to 1. Because that would make our lives really easy, right? When I multiply this out, I get secant squared x minus tangent squared x. And secant squared x, I can substitute for that, right? Secant squared x equals 1 plus tangent squared x minus tangent squared x. And we just end up with a 1 in the denominator, and we have our secant x plus tangent x. So not too bad. Not too bad. I've done this one. I have it written down here, working through this one, where I turned this all into sines and cosines. Way more difficult than multiplying by the conjugate. I have a new one where I worked on this side to get it to equal that side. Little more difficult that way also. This is really nice. Goes pretty quickly. All right, questions on what we did there? I really like doing verifying trig identities. To me, it's like work doing a puzzle. And the more you do it, the more you see little tricks and little ways. You start being able to predict. Oh, I need a secant squared x to get rid of that tangent squared x, so I need to do this, so you can see where things are going. All right, let's look at. We'll look at a couple more. Cotangent squared x just cotangent x, cosine x. And we want to show that equals 1 over tangent x, secant x. So which side do we want to work here? Because it's kind of hard to tell which one is more complicated. I would say fractions in general are a little more complicated than multiplication. So let's work the right. So I'm going to say this is what I skipped a step here. We want to show that cotangent squared x cosine x equals cosecant x minus sine x. So we still want to work the right side. I think the subtraction is a little more complicated than the multiplication. So what do I want to do here with the right side to start working on this? What could we do? What's the most obvious thing? What's cosecant x? 1 over sine x. So I'm going to say 1 over sine x minus sine x. Now I need to subtract these two things. So what do I need to do to subtract those two? Common denominator. So I'm going to multiply this by sine x over sine x. This is looking good already. I have 1 minus sine squared x over sine x. 1 minus sine squared x is cosine squared x over sine x. Can I rewrite this as cotangent squared cosine x? This is cosine x, cosine x, and I have 1 sine x in the denominator, so that's cotangent x, cosine x. So that one turned out not too bad. Questions there? All right, let's look at one last one. Still verifying. All right, so which side do we want to work here? Left side? I think the left side looks more complicated. That squared makes it look complicated. So let's work the left side. So I'm going to say we could work either side on this one, so we can just pick the left side. Do we have a different way that we could write cotangent squared theta? We know that cotangent squared theta plus 1 equals cosecant squared theta. So cotangent squared theta equals cosecant squared theta minus 1. So let's rewrite this. So we have a cosecant squared theta minus 1 over 1 plus cosecant theta. What can we do with that cosecant squared theta minus 1? What is it? Factor, we can factor it. We did one of those, we did a factoring problem on the board here earlier. So we're going to factor this. So this is cosecant theta plus 1 times cosecant theta minus 1 over 1 plus cosecant theta. 1 plus cosecant theta is the same as cosecant theta plus 1. So what can I do with this? Cancel that out. And I get cosecant theta minus 1. What do I do here? Write cosecant theta. That's the one thing we know how to do, right? Right, cosecant theta is 1 over sine theta. So we get 1 over sine theta minus 1. What do we need to do to subtract these two? Common denominator. So I'm going to multiply this by sine theta over sine theta. I get 1 minus sine theta, just like we wanted, over sine theta. And we're done. All right, questions there? So what we're doing when we're verifying identities, we're using what we know about identities, we're using what we know about algebra, and we're adding, subtracting fractions, we're factoring, combining all of these techniques to show that we can get from one side of our equation to the other side. All right. Homework. All right, there you go.